So you can see these are ICs. These ICs contains millions of transistors, diodes, and resistors inside it. So a silicon chip is used to make these ICs. Now you can see this is the external view of ICs. Right, when you look from top, you can see some numbers printed on the IC. Now here we have some notch. Here we have zero mark. Now when we labeling these terminals, we should start from here. We should start from here. Then we should label anti-clockwise direction. Now this is 1, 2, 3, 4, 5, 6, 7, 8. So in this IC, there are 8 terminals. To study these ICs, no need to know about the internal structure of this IC. For example, when you are using mobile phone, you don't have to learn about the internal structure of the mobile phone. Without knowing it, you can use the mobile phone. So this is like this. To use the ICs or integrated circuits, you don't have to know about the internal structure of the IC. Right, children, now you can see this is the circuit symbol of IC. These ICs are also known as operational amplifiers. The reason is this can be used to do mathematical operations like subtracting, adding. So we can use this IC to do mathematical operations. Therefore, this IC is also known as operational amplifiers. In short names, op-amps. Right. Now these are the terminals. Now here you should be able to identify these terminals. Now here we have, first thing is we should power up this IC. We should power up this op-amp. To power up, we have two terminals. These two terminals are used to power up the op-amp. Now next to this negative one, here we have positive. This is the positive terminal of the power supply. Therefore, this is VS. VS means power supply. This is the supply voltage. This is positive supply. This is negative supply. Negative VS. If the question says plus or minus 5 voltage is supplied to the operational amplifier op-amps, that means this is 5 volt, positive 5 volt. This is minus 5 volt. That's the meaning of that. Plus or minus 5 volt is supplied to the op-amp. That means this is 5 volt. This terminal is minus 5 volt. Right. This is what? This is the output. This is output. VO. Then these are the inputs. Now here we have two inputs. Now as you can see, here we have a negative input. We have positive input. This positive input is known as non-inverting input. This is known as inverting input. This positive one is, this input is known as, let's right here now, let's say this is V in, let's say this is V in plus. V in plus. This is V in input. This is negative input. So this is known as non-inverting input. This is known as inverting input. Right. This is inverting input. This is non-inverting input. These two terminals are used to power up the op-amp. This is the output. In additionally, there is another one. We should connect this op-amp to the ground terminal or earth terminal. That is 0 volt. We should connect this op-amp to this ground earth terminal. 0 volt. Right. Now, don't misunderstand. These two terminals are used to power up the op-amp. These two terminals are used to give the input to the op-amp. We have two inputs. One is plus. This is for non-inverting input. This is inverting input. These two terminals and together with the 0 volt is used to power up the op-amp. That means we can use this plus VS, minus VS and 0 volt earth terminal used to power up the op-amp. So earlier I told you this op-amp can be used to do mathematical operations. Not only that, this op-amp mainly is used to amplify voltage signals, both DC voltage signals and AC voltage signals. So DC means its voltage is constant, not changing. AC voltage signal means it's changing with time. This is AC voltage signal, this is DC voltage signals. So this op-amp can be used to amplify both DC signals and AC signals. This picture shows the way to power up the op-amp. Now you can see two batteries are used, both are 6-volt batteries. So therefore the potential difference across the two terminals of the battery is 6 volt. Now this is the earth terminal. Therefore, the potential of the earth terminal is 0 volt. Since the potential difference across the battery is 6 volt, if this is 0, this should be 6 volt. In this battery also, potential difference is 6 volt. If this is 0 volt, this should be minus 6 because this is the this potential of this terminal should be greater than this one. If this is 0, this should be minus 6. Now, this is the way power up the op-amp. Actually, this power up part is that much not important to do questions. Therefore, don't worry about this power up part. Right, children. Let's say this op-amp is properly powered up. Now let's say this negative, this input is grounded. This terminal is grounded. Then if we provide input signal to this positive input, then the output is definitely going to be an amplified one. So the output is amplified, and also you can see there's no any phase difference. There is no any phase difference. Therefore, this positive input is known as non-inverting input. Non-inverting input. So output is amplified, the signal is amplified, and also there is no any phase difference. Right. Then let's see what will happen if we feed this signal into the negative input while this positive one is grounded. So now this positive input is grounded. That means the potential is 0 here, 0 V. Then signal is fed into this negative input. Then obviously this signal is going to be amplified, but the output is inverted. Now this is the amplified signal, but is inverted. This is input, this is output. Output signal is inverted and also is obviously amplified. Therefore, this terminal is known as inverting input. Inverting input. Right, now here we have a op-amp. Now let's say this op-amp is properly powered up. Now this V2 input is grounded. That means this is the inverting input. It is grounded. Therefore, voltage is 0. Now this is the non-inverting input, a signal. A signal is provided, is fed into this non-inverting input. Right, children? Now here, this is the V1. So this signal is fed into this non-inverting input. Right. So actually this op-amp is doing is this op-amp going to amplifies V1 minus V2 difference. That is the difference between the voltage difference between non-inverting input and inverting input. So this op-amp going to amplifies V1 minus V2 difference. Therefore, this op-amp is known as differential amplifiers. Differential amplifier. This is another name for op-amp. Right, children. Now look at here. Now this is the input. Now this input is fed into this non-inverting input. Now this is the signal. Then what is the potential at V2? It's 0. Then what is the V1 minus V2? Now this is This is V1. V1 is fed into this non-inverting input. Now this is V2. V2 is 0. It's grounded. This red color line represents 0 voltage. Is grounded. This is V2. Then what is the V1 minus V2? V1 minus V2 equals to V1 itself, because V2 equals 0. Therefore, this is 0. Therefore, V1 minus V2 equals to V1. So input is itself. Therefore, this is the output. Output is non-inverted one. It is amplified one. It is amplified. That means if V1 minus V2 is greater than 0, we have a non-inverted output. Non-inverted output. Right, this V1 minus V2 is known as differential input. V1 minus V2 is known as differential input. This op-amp amplifies this V1 minus V2 difference. This op-amp amplifies this differential input. Right, now let's see this one. Now let's consider this op-amp now here. Again, this is properly powered up. Now let's say here, now this positive input, that means the non-inverting input is grounded. Therefore, this is voltage is 0. Then this is V1. Now V1 is 0. Now this line, this is V1 is 0 volt. Right, children, now we are feeding signal into this inverting input. Now this is the signal. We are feeding this input to V2. Then what is V1 minus V2? What is the differential input? V1 minus V2. V1 is 0 because this is grounded. 0 minus, now this is the V2. It's V2. So equals minus V2. So differential input is negative of V2. Now this is the V2. Then the differential input is negative V2. Then this op-amp is going to amplify negative V2. Now this is V2. Then what is the negative V2? This is the negative V2. This is negative V2. Now here I'm going to V2. This is V2. I'm going to do this V2. Now this is the V2 signal. Now this V2 signal is fed into inverting input. Then what is the 0 minus V2? 0 minus V2 is minus V2. Then I will draw that. Now this is minus V2 signal. Now this is the differential input. Now what happens is this op-amp amplifies this differential input. Then this is the output. So it amplifies this differential input. Now this is the output, VO. If V1 minus V2 is less than 0, that means if V1 minus V2 is negative, we have inverted output. Amplified inverted output. If V1 minus V2 is greater than 0, we have non-inverted one. Actually, this is V2. This is the input. This is the V1. V1 is fed into positive input. That is non-inverting input. V2 is 0. Then this is differential input. Then this op-amp is going to amplify this differential input. Then this is the output. Frequency is same. So you can see the frequency is same. Frequency, the time it takes to complete one cycle. Now this is the time period. This is the time period it takes to complete one cycle. Now you can see output. So it's also same. Time is same. Therefore, nothing happened to the frequency, but the amplitude increases. This case and this case, both cases, amplitude increases. That means it is the input signal is amplified. Right, children, now we can see these two signals are fed into the op-amp. V1, this signal is fed into the non-inverting input. V2 is fed into the inverting input. Then what is the V1? This is the V1, red color one. This is V2. Then what is V1 minus V2? V1 minus V2 is the differential input. So the op-amp is going to amplify this V1 minus V2. That means this differential input. Now we can find. Now we can see when time equal to 0, both are 0. Therefore, what is the V1 minus V2 when time equal to 0? 0. 0. Right? 0. Then we can see when time equal to this certain value, V1 equals 4, V2 equals 3. When time equal to this certain value, what is the value of V1 minus V2? Is equals 4 minus 3. 4 minus 3 equals 1. Therefore, the differential input equals to 1. Therefore, this value should be equals to 1, not 2. This should supposed to be 1. Now, this is 1. When time equal to that certain value, V1 minus V2 equals 1. So, you can see this green color curve represents differential input. This is the differential input. This op-amp amplifies this differential input. Now, therefore, output is like this. Output is like this. This is the differential input. Output is like this because this op-amp amplifies this differential input. This will be the output. Output will be like this. Output is like this. So op-amp amplifies this differential input. Now look at this A-level exam type question. Right here, now you can see this is the V1. Usually they will give question like this. Now V1 is a constant. V1 constant is 1.5 volt. So this voltage is provided, fed into the non-inverting input. So it's 1.5. Therefore V1 equals 1.5. Now V2, this is the signal. This signal is fed into the inverting input. It's an alternative one. It's triangular shape. Right. So you can see the maximum value is plus 2.5. The minimum value is minus 2.5. Right. Then when time equal to 0, this is time equal to 0. So let's calculate what is the differential input when time equal to 0. When time equal to 0, what is the V1 minus V2 value? V1 equals 1.5 is a constant. It's always constant. What is the V2? V2 equals 0. That means 1.5. That means when time equal to 0, differential input value equals 1.5. Now you can see both inputs are provided here. You can see clearly. Then what is the V1 minus V2 when time equal to 0? 1.5. This is 1.5 over here. Then let's calculate what is the V1 minus V2 value when time equal to at this point. V1 is 1.5. V2 value is plus 2.5. Then what is the V1 minus V2 value? V2 minus V1 minus V2 value equals 1.5 minus 2.5. So this is a negative value. This is minus 1. So when time equal to this certain value, V1 minus V2 is negative 1. Right? Right. See? When time equal to this certain value, V1 minus V2, this red color graph represent, curve represent V1 minus V2 differential input, then it's minus 1. Similarly, you can find out other values. You can find out quickly. Then this red color line represent differential input. Then this op-amp is going to amplifies this differential input. Then this would be the output. The output will be like this. 0 is 0. It's like this. This graph is multiplied by some number, positive number like this. This is the output. We can get this output by stretching this differential input by some number. This is the amplified one. This is the amplified signal of the differential input. Continue. So you can see this is V1. V1 is a constant. It's a 1.5. This signal is fed into non-inverting input. This is the inverting input. This triangular shape alternative signal is provided into the inverting input. Then let's find out what is V1 minus V2. V1 minus V2 is the differential input. Now in this graph, we can find V1 minus V2. When time equal to 0, V1 equals 1.5, V2 equals 0. Then what is the V1 minus V2? V1 minus V2 when time equals to 0, V1 equals 1.5, V2 equals 0. This equals 1.5. Therefore, this graph start V1 minus V2, that graph value start from 1.5. Now you can see clearly when time equal to this certain value, both V1 and V2 are same. Therefore, what is the V1 and V minus V2 is 0. Therefore, 0. Then here, when time equal to this value, a certain value is given, this is 2.5 plus 2.5. Then when time equal to this certain value, what is the V1 value? V1 value is 1.5, V2 value 2.5. Then what is the V1 minus V2? 1.5 minus 2.5, that is minus 1. So minus 1 is over here. This is minus 1. Let's say this is minus 1. Right? That means over here. Then if you can find several values like this, no need to find all the values because it takes a lot of time. Just few values is enough. This value and this value here also, at here also we see at this certain value, this when time is equal to this certain value, again both are same. Therefore, this curve line should intersect this point because it's 0. V1 minus V2 is 0 again here. Therefore, if you draw the graph, it's like this. You can draw it. Right now, you can see here at this side. Now we are going to this V2 becomes negative. Beyond this point, see, beyond this point, V2 becomes negative. After this point, V2 becomes negative. Therefore, V1 is 1.5 minus V2. So this is negative. That means 1.5 minus some negative value. Therefore, minus into minus become positive. Therefore, you get 1.5 plus some number. So it increases rapidly. And this is the differential input. Now, the differential input is like this. This is the differential input. Now, this is the input. This is the differential input. This op-amp is going to amplify this differential input. Therefore, output is like this. Output is amplified version of this differential input.